Have you ever looked up at the night sky and assumed the stars would always be there? It feels impossible to imagine a universe without them, considering every human civilization in history has lived beneath those exact same glowing lights. Right now, our cosmos is incredibly active. Astronomers estimate there are roughly 200 sextillion stars actively burning out there. That is a 2 followed by 23 zeros. To maintain that massive number, new stars are being born every single second. Gravity slowly squeezes giant clouds of drifting gas and dust until the intense pressure forces nuclear fusion to ignite at the core. But those burning cores are finite engines. Every single one operates on a ticking clock, requiring enormous amounts of raw hydrogen to survive against crushing gravity. This chart tracks cosmic star formation. It peaks 10 billion years ago and drops steadily. The most active era ended long ago. Essential hydrogen is disappearing. Supernovas blow it into space, while the rest is swallowed by black holes or locked inside dead stars. Today, the universe is producing only a tiny fraction of the stars it made billions of years ago. The greatest fireworks show in cosmic history is behind us, and the universe is mechanically winding down toward an inevitable end. Fast forward a few trillion years. The massive, bright blue stars that burn through their fuel in a few million years are long gone. Even steady, medium-sized stars like our Sun have completely died out. This visualization compares the fuel consumption of different stellar classes. Watch the massive blue sphere drain in seconds, while the yellow, sun-like sphere lasts moderately longer. But look at this tiny red sphere. This is a red dwarf. They burn their fuel so slowly that a single red dwarf can continue to shine for up to 10 trillion years. But as those 10 trillion years pass, space itself is expanding faster and faster. Distant galaxies will eventually be pushed beyond our visible horizon, completely isolating the remaining star systems. If you lived in this incredibly distant future, you would look up into the night sky and see a single, lonely galaxy surrounded by pure darkness. You would have no way of knowing that a wider, populated universe ever existed. Eventually, even the red dwarfs reach their limit. They do not explode. They simply exhaust their final drops of hydrogen, stop glowing, and cool off into dark stellar remnants. When that final red dwarf cools, no new stars will ignite to replace it. For the first time since the first galaxies formed, the sky will contain almost zero shining stars. Astronomers refer to this as the degenerate era. The universe becomes a pitch-black graveyard, populated exclusively by dead stellar corpses like white dwarfs, heavy neutron stars, and the invisible pull of black holes. Light becomes exceptionally rare, though it isn't entirely extinct yet. Over billions, sometimes trillions of years, two of those dead white dwarfs can drift into each other's gravity and slowly spiral together. When they finally collide, they trigger a Type A supernova. It is a fleeting, hyper-brilliant explosion that briefly outshines entire galaxies before fading out, returning space to permanent darkness. Now imagine time passing by 10 to the power of 100 years. That number is called a googol. It is a 1 followed by 100 zeros, a duration so fast that it dwarfs the current age of the universe many billions of times over. By this point, the final active process left in the cosmos is something called Hawking radiation. This diagram illustrates how black holes very slowly leak tiny amounts of energy into the void as radiation. A black hole with the mass of our Sun would take 10 to the 67 years to disappear entirely. The absolute largest supermassive black holes would survive until the clock hits 10 to the 100 years before finally evaporating into faint, scattered radiation. After that last black hole evaporates, the universe reaches a state of absolute eternal darkness. The darkest objects in the cosmos will have ultimately outlived the brightest. What comes next is an unimaginably cold, starless void, characterized only by occasional tiny flashes from very rare particle interactions. But if we pull our perspective rapidly back out of the dark and into the present day, we find our universe is only 13.8 billion years old. Look at this timeline comparing our current time frame to the future. Against this infinitely stretching dark bar representing the trillions and googles of years to come, humanity exists in this microscopic, brightly glowing sliver at the very beginning. We exist incredibly early. Most of the universe's timeline will be silent and dark. We happen to be living during a brief, fleeting golden age of light that the vast majority of the future will never get to experience. Every constellation you point out, every sunrise you watch, and every glowing galaxy captured by our telescopes are cosmic wonders that future generations of the universe will simply never witness. The stars you see in the night sky are temporary. They stand as beautiful, glowing evidence that you happen to exist during the absolute greatest light show the universe will ever know.